Welcome to the Sun today for the 9th of January 2022. Breaking news, we had a geomagnetic storm last night. So what are you going to talk about today? Well, first of all, this background image is interesting. It's a picture from the SOHO coronagraph. The bright object across the top is Venus. Venus is currently between us and the Sun and is slowly overtaking us, as you'll see in the video that I will show later. As far as sunspots are concerned, we have 3 new groups, all of them relatively modest. There were no major flares or coronal mass ejections. The solar wind is the story today, when a co-rotating interaction region hit the Earth. That created a geomagnetic storm and aurora. So we're going to talk a little bit about that. And then also, under any other business, what is a co-rotating interaction region? Let's first take a look at the sunspot groups on the Sun at the moment. And we have some new ones from yesterday. We still have active region 2924, but you'll note that it is simplified significantly since yesterday. If you look at the spot in the bottom left-hand corner, you see there's a white line crossing the sunspot. That's called a light bridge, and is usually an indication that the sunspot is breaking up. We have the new region that we saw yesterday in the northern hemisphere, just west of Sun Center. That has not particularly changed. We have another new region popping up between active region 2924 and active region 2925. This has got 2 fairly substantial spots in it at the moment and may grow some more in the coming days. We have a new region on the northwest. We have a new region on the northeast limb. It's obviously a very large area of scattered plage, so it's probably the breakup of an old, larger region. You can see a few tiny spots scattered through the plage region. Another new spot region coming over the southeast limb, and this is obviously a mature spot surrounded again by broken plage. So this too is an old region that has decayed away, but has at least left one large spot. Then we have active region 2925, which looks very similar to what it did yesterday. It may be breaking up a little since yesterday. This is a picture of the official sunspot number as recorded by the SIDC in Belgium, and you can see that the current sunspot number is nearly 60, and that is higher than it was at the same time during the last rotation, one Carrington rotation, or 4 weeks ago. Will it continue to rise like it did last time? I somehow don't think so, but we'll have to wait and see. You can see from the GOES X-ray flux that the Sun has been relatively stable with just a few minor B flares during this period of time, no C flares or larger. So this is fairly quiet and typical of mature sunspot regions. So let's take a look at some movies. First of all, we'll take a look at the sunspot movie, and I particularly want you to take a look at active region 2924 and how the sunspots evolve. As we have no flares to look at, let's take a look at the corona, at least the quiet corona. And for that, we're going to use the 193 angstrom movie from the AIA instrument on SDO. Lastly, take a look at the SOHO LASCO movie. This is to look at the outer corona and looking for coronal mass ejections. And as you can see, there's nothing particularly spectacular going on. You can see there's a fairly major change in the solar wind about midnight yesterday. First of all, the BZ component, the vertical component of the solar magnetic field, started oscillating between north and south. And this could cause interactions between the Earth's magnetosphere that can lead to aurora, in other words, geomagnetic storms. The density rose for a time to 30 or 40 particles per cubic centimeter. That's quite high. The speed of the coronal wind jumped to over 500 kilometers per second for a time, and then the temperature jumped to between 300,000 and 400,000 degrees Kelvin, which means that this material is more coronal in origin than photospheric. This all resulted in a geomagnetic storm, admittedly a low-level one with Kp index equals 5. That translates to a G1 magnetic storm. So basically the effect of that is to get some nice aurora. But what is a co-rotating interaction region? It's when these two different flows of winds interact with one another, they have an interface region, and either side of that shocks can form, both forward shocks and backward shocks, and those can accelerate particles to exceedingly high energies. And when they do that, you can get geomagnetic storms if those hit the Earth. And this is what actually happened yesterday. We had aurora at very high latitudes. It's a very beautiful aurora at high latitudes. But none of these were causing problems with our power grid or communications or anything of that sort. This is a relatively mild storm, as I mentioned before. So what conclusions can we draw from all of this? First of all, we have some new spot regions appearing over the east limb, and there may well be more to come. And a low-level geomagnetic storm was caused by a co-rotating interaction region. So stay safe until next time, and goodbye.